Welcome. My name is Eliraz Levi, and I'm from the research team at Hunters. Today, we are going to cover many cool topics, starting with the threat overview. We will review the main assets, accounts, and tools that are commonly used in hybrid environment in general, and specifically in the attack scenario we are going to present. Next, we're going to move on to an attack scenario from the offensive side. We are going to demonstrate how such an attack evolves, as well as the challenges from the adversary perspective. Then we will switch hats and take a look at the defensive perspective by walking through a story in the Hunters portal and delve into some of the very cool detectors there that shed light over this attack. But first, let me introduce my partners in crime. Alon Klayman, a security researcher from Team Axon, who is going to take us into the attacker's mindset by demonstrating exciting attack tools and techniques. We also have with us Asaf, a security researcher here at Hunters, who is going to guide us through very cool detection methods and investigation context integrated within the story in the portal, and that can assist the SOC analyst to investigate the attack scenario we are going to present. But before we jump into the offensive and defensive aspects, let's do a short overview that will assist us in understanding the attack scenario later on. So the synchronization between the on-prem environment and the Azure AD environment can be managed by a different method and architecture. First, with password hash sync, PHS, pass-through authentication, and federation services. Threat actors can use these types of architecture to move laterally between the on-prem environment to the cloud environment, get permission to the Azure AD, and by that, access to the Azure resources. A good example for that was presented by Microsoft in April this year, where they revealed an operation associated with an Iranian group called Mercury. They are also known by different names, such as Mango Sandstorms and more. Yeah, this group used different tools and techniques and move from on-prem environment to the Azure environment while they conducting a massive destruction over Azure resources, as well as data exfiltration from mailboxes. A key area that contributes to the success of Mercury attacks and in general contributes to the success of such attacks is the synchronization service implemented by Azure AD Connect application. This Microsoft application is designed to assist in and actually manage the synchronization between on-prem AD and Azure AD. It synchronizes objects in Active Directory with objects in Azure AD. It can be deployed on DC servers, but usually it is deployed on dedicated and separated servers on-prem. So let's dive a little bit to this application and the service accounts that it uses. So as you can see in the diagram, this application actually synchronize between the on-prem environment and the Azure AD, and it is doing so by using 3 service accounts. The first is the ADDS connector account, also known as the on-prem connector, starting with msol_, and as the nickname of the MSOL account, as it sounds. And the role of this user is to read and write data from the on-prem AD to the Azure AD Connect. As you can see in the picture, it also have the replicating directory change permission. And if these permissions looks familiar for you, you're right, these are the permissions that are required for this sync attack. And we will touch it in a minute. Another service account is the AD Sync service account. It runs within the Azure AD Connect server, and it runs the sync service and read-write from the SQL Server database located on the Azure AD Connect server. The third service account is the Azure AD Connector account. Unlike the previous two service accounts, this account is not an on-prem account, but a cloud account. It has a very unique name pattern, start with sync underscore, then the AD Connect server name, and then the random number which represents the installation identifier of the environment. This account is also known as the sync account because how it starts, and it has a very unique role in Azure AD called the directory synchronization accounts. To summarize, this the functionality these three accounts provide us, we can look at the following table. We can see the first two users are on-prem and the sync user is a cloud account. And we can also see the potential abuse of each of them. For example, for the MSOL account, because of its permission, the permission it has, as we mentioned before, it can be abused to conduct a DC sync and by that to get control over the entire on-prem environment. And it also can be used to reset password for some accounts. The AD Sync account, because it located and actually managed the synchronization service on the Azure AD Connect, it can be abused in order to access to the MSOL and sync accounts. And we're gonna see an example for that when we're gonna use one of the tools we are going to mention soon. And the sync account can be abused in order to reset password and by that elevate permissions in the Active Directory. Okay. Beside the Azure AD Connect server and the service accounts associated with it, we are going to present and use some different tools during the attack scenario. The first is the AD internal. This is actually an administration and hacking tool that can be used for Azure AD and for Office 365. It includes some built-in capabilities that can make the life of the threat actor very convenient. In addition to this module, we are going to use two other modules, the Azure AD module and the Azure PowerShell module. Unlike the AD internal that is usually used for hacking purposes, these two modules are usually used by IT specialists. But of course, as threat actors, we can also use them in order to get information about Azure ID and Azure resources in general, and also run some operation on the environment. So this was a short overview, and now we are going to move to the attack scenario from the offensive side. Alon, stage is yours.
Thank you, Eliraz. Okay, before I continue, let me please just quickly share my screen. Can you see my screen?
Yes.
Great. Okay, so the following part of this webinar will include, as Eliraz said, an attack scenario. Basically, the two following parts will be relevant and be based on this specific attack scenario. I will present you now the offensive side of this attack scenario, and right afterwards, Asaf will show you the defensive part of it. Basically, the offensive side will include some kind of repetitive pattern. As you can see on screen, it will include high-level network diagram, attack video, summary slides, which basically will show you the main parts related to each of the attack videos that we just saw. And I also want you to pay attention to the detected banner that will appear in some of the slides that you will see throughout this part. And basically what they need to tell you is this, those parts are basically detectable using the out-of-the-box detectors of the Hunters platform. So this flow will repeat itself 4 times. And basically you don't need to feel pressure to actually keep up and track every command that you see in the attack videos. You'll need to understand the basic flow, and you also will get the slides themselves that you can see the most relevant commands in. So that's it basically. And before we jump into the commands and what exactly the attacker did, because we show you the offensive aspect of this attack scenario, I would like to show you this specific network diagram. This network diagram is related to Axon Corporation, which is basically just a made-up corporation that we created. Nothing to do with Team Axon of Hunters, so don't you worry about it. There are not resources that are related to us in any way. So basically, you can see here this overview, which is pretty high-level one. It includes 2 main parts of the infrastructure of this organization. One part is the on-premises infrastructure, and the other one is the Azure infrastructure. Basically, the attacker gained an initial access to this specific host that you can see here, Ronaldinho Gaucho's PC. This is standard host on the on-premises infrastructure, and our attacker had some kind of previous knowledge about the infrastructure and exactly what he wanted to gain access to. And the target of this attacker was to gain access to the specific resources that are located on this specific resource group on the Azure infrastructure. Which means you would like to get access to one of those servers that you see here with a little crown on top, and to the key vault that is also located on the same resource group. This is basically the main resource group of the organization. It includes the production servers. All of them are basically a replication one of the other. And on each one of them, there is an application which is installed on them and can be accessed using a set of credentials, which is a standalone credentials, which means the credentials for the application within the servers is a standalone, is managed in some kind of standalone way. It's not managed by the Azure Active Directory or by the On-Prem Active Directory. The credentials, I can tell you from now, exist on this key vault. So basically, our attacker needs to gain access to 2 sets of credentials. One to gain access to the server itself, and the other to gain access to the application which resides inside the server. So the attacker unfortunately tried some kind of some different techniques to gain the initial access he wanted, and gained access to the on-premises infrastructure, which is not great for him, but it's something. And he will need to do some kind of things and to laterally move from the on-premises to gain access to the resources that he actually cares about. So without further ado, let's start with the first attack video, which demonstrates the first phase of this attack conducted by our attacker. Okay, so let's start the video. I will go over it really quickly. If you miss any command, don't worry about it. It's really, really okay. So basically, you can see here that the attacker gained some kind of interactive access to Ronaldinho Gaucho's PC. This PC, the one host that you already saw previously, And he wants to gain some kind of understanding about where he's actually located in the infrastructure because he didn't know. He didn't have the great network diagram that you just saw. So to do so, use those commands, some kind of enumeration to get the information about the local administrator, the domain administrator, et cetera, the host name, the user that he gained access to, use the specific dsregcmd command, which is also an important command that allows him to get information about the connection between this host to Azure Active Directory to see if it's actually related to Azure Active Directory in any way. You can see that he finds the name of the user, the name of the host. He understands that the user is low privileged host, a user account, which is not a local administrator. And he can also see that there are only two users or groups that are local admins, which are the domain admins groups, which is basically by default the case, and the HDADM04, which is also a local administrator user account. And there is tons of enumeration here. You can see that the Azure AD joined is marked as yes, which means that this host is joined to the Azure Active Directory infrastructure, which is great because he understands that now he has some kind of connection to the Azure Active Directory and to the Azure infrastructure as a whole. And you also see the domain administrator, and none of them is Ronaldinho Gaucho, which is the user account that he gained access to. So basically, it's not a great way to start the day for the attacker. He knows that he has some kind of low privileged user account, but it is what it is, and he needs to move forward. And he continued with some kind of enumeration, specifically enumerating the domain user account related to the MSOL, which is the MSOL user account that Eliraz talked about previously. The cool thing about this user account is in the description of this user account, you can see the name of the Azure AD Connect server on the on-prem infrastructure, which is really great for the attacker to know where we need to move now in order to privilege, to conduct the lateral movement that he wants to conduct. He tries to see if there is a connection, an available network connection towards this host, if the port 3389 is actually open towards this AD Connect server, and he sees that there is a network, an available port open, 3389, which is the RDP port. And he tries to access to this specific server using the credentials that he already has, the credentials of Ronaldinho Gaucho, and he sees that unfortunately, Ronaldinho doesn't have enough permissions to gain access to the server, which makes sense because as we said earlier, Ronaldinho is low privileged user account. He has no special access to resources on the infrastructure. So he tries to look for some kind of network shares using this command. He finds a specific network share, and what you do when you find the network share, if you're an attacker, you try to look in files and to see if you can find any cool information, sensitive secrets, or any kind of credentials that can help him to move forward. And this is exactly what he did using a specific script that will appear on screen in just a few seconds. And you will see that he found some set of credentials, some of them not really relevant, some of them are relevant, as you will see in a minute, because in one of the files that he found using this specific script, he found the credentials of the HDADM04 user account, which is a local admin on this specific host, and of course the password of it. And in addition, I can also tell you that the HD, the convention of HD is actually a help desk. So this user account is basically an help desk user account, which means that in this specific case, it has a local administrative privileges to all of the resources on the on-prem infrastructure, which is great for the attacker. It's something that happens quite a lot. And yeah, the attacker was a bit lucky in this situation, and he used the credentials that he just found to see if they are actually valid. And he opened a new PowerShell prompt using the credentials that he just found, and found out that the credentials are really valid credentials and he can use them, which is great. So now he is a local administrator on the host, on the initial foothold host that he gained access to. And he uses the privileges that he has to install the AD internals tools that Eliraz talked about before. And as you can see here on screen, he installs the tool. The tool is successfully being installed on this device. And the following thing that the attacker will do now is to see maybe he can laterally move using this user account to the Azure AD Connect server. And surprise, surprise, he can do so because, as I said before, this is an help desk user account and he has a local administrative privileges to all of the resources on the on-prem environment only. So he uses the enter PS session command basically to create a PS remoting session towards the AD Connect server, which name is PRT VM new 04, as we found out earlier using the enumeration. And our attacker gained access to the AD Connect server, which is amazing for him. It's a huge milestone in this kind of attacks. And yeah, so we finished with the first video. And I know it's a lot of information, so I would like to quickly recap what we just saw. So first we saw an enumeration. He found out that the HDADM is a local administrative user account. Basically, it's a local administrative user account throughout all of the resources on the on-prem infrastructure. By the way, remember the detected banner. It means that we have an out-of-the-box detection for this kind of things in the Anders platform, or Asaf will tell you more about it in the following part of this webinar. Additional part was the finding of the AD Connect name, AD Connect server name. He tried to laterally move using the Ronaldinho credentials, didn't manage to do so, found this new set of credentials, and again, tried to laterally move and managed to do so, and is now accessible to the Azure AD Connect server, which is a great thing to achieve, especially if you are a lucky attacker like ours, okay? So the next part of this demonstration continues from the exact same place. The attacker gained remote interactive access towards the AD Connect server. He uses the exact same command to install the AD internals tool, but this time with a specific purpose in mind. He wants to get the credentials of the two important user accounts that Eliraz talked about before, the MSOL user account and the sync credentials, the sync user account credentials. Why he wants to do so? Because those user accounts are super important. And yeah, the AD internals tool provides you the ability to do so. And as you can see now, he will do just that. He used the import module to import the module of the AD internals and uses, uses a specific command to actually import the credentials of the specific user's account that we talked about before. And you will see the credentials of them in a moment on screen. We blurred the credentials actually, but you will see part of it. But you have to trust me, those are the credentials of the sync user account, and the MSOL user account was right beneath it, okay? So basically now the attacker has the clear text credentials of the sync user account, which is a great thing for him. He moves back to the initial foothold machine, which is the VM new 02 host, because he wanted to continue the attack from this host, maybe because he didn't want to make much noise on the AD Connect server, which is a more sensitive asset. And he uses the sync user account and the password of it that he just found out to basically communicate with the Azure Active Directory using the AD internals tool. So basically you get an access token, and he will try now to communicate with the Azure Active Directory using the specific credentials of the sync user account. So basically from the perspective of the Azure Active Directory, he sees that the sync user account just connected to it, okay? He uses two tools for this step, the Azure AD module and the AD internals. Doesn't really matter, each of them provides him different functionality. And what he does now is basically an enumeration of all the roles that are available and actually being used in this part, in this tenant, in this Azure AD tenant. And he sees here the global administrators, which of course are being used in the tenant, and some other ones like the application administrators, etc., etc. I paused the video because I want to provide you with initial thing that doesn't appear in the video. The attacker tried to gain access to the global administrator user's account, and he found out that all of the global administrators has MFA enabled for them. So basically it's a bad luck for him, because now he knows that even if he uses the sync user account, which has the capability to reset the passwords of all of the users, as Eliraz said before, even if he reset the password of a global administrator user account, you won't be able to access it because there is an MFA enabled on it. So he decides to look for other roles. In this case, he specifically looked for the application administrator role, which is a very powerful role in Azure Active Directory. And basically, a lot of attackers are using this role and trying to abuse this role as part of their attack. And what he did here, he found out which users are basically part of this role, basically has this role attached to them. And he found out that Guti Hernandez, one of the organizational employee, has the permissions of application administrator. He enumerates further, and found a specific string related to Guti Hernandez. This string is called an immutable ID or source anchor. It can be used interchangeably. Basically, this string is some kind of unique identifier of the object. And it also used behind the scene for the replication between the Azure Active Directory and the on-premises Active Directory. And all he needs to do now that he uses the sync user account is to basically provide the source anchor, the value of the source anchor, and the password that he wants to set for this specific user account that has the source anchor as an attribute of him, which is Guti Hernandez, as we just saw. And Azure Active Directory, from his perspective, thinks that the sync user account just reset the password, and it's something that happens a lot of time. And for, the attacker now can use this new password and access to Guti Hernandez user account, which is an application administrator, and it's super, super powerful for him. So the second video is now over. Quick recap, because I know it's a lot of information to deal with. Here you can see the usage of AAD internals in order to fetch the credentials of the sync user account and the MSOL user account that had been conducted by the attacker. In addition, you can see here that the attacker enumerated, found some specific roles that are being used on this infrastructure. And in addition, he found out that the Guti Hernandez user account is part of this specific role. And that's it. He gained access to Guti Hernandez credentials, basically resetting the password of Guti Hernandez. And yeah, now we can use it. Eliraz, I saw that you raised your hand. You wanted to say something?
If you can please return 2 slides back.
Yeah.
Great. So yeah, few posture insights we can derive here. First, regarding the finding of the plain text password, that this finding actually enabled us to access remotely to the Azure-related Connect server. We have seen this technique too many times before. And of course, a lot of effort should be put in order to increase the user awareness of not storing such files, such sensitive CRED files with the clear text passwords. Besides that, we as defenders can adopt a proactive approach and try to look for such sensitive files and alert on them before the red teamer or before the threat actor. It can be done, for example, by running scripts that look for sensitive files in OpenShare, shares, etc. And another posture insight that is related to the access to the Azure-related Connect server is that I think us being able to access this server, it emphasizes how much it is important to treat this server as a critical and highly sensitive asset. And hence, think about restrict access to this asset, both from identity level and network level.
Yeah, I totally agree. The AD Connect server, basically, as I see it, and I think it's some common thing to think, basically, it's one of the most important servers on the on-prem infrastructure. I think that it should be treated at least like the domain controller, because as you saw, you can get the credentials of highly sensitive user accounts, and you can do really, really big damage by getting those credentials. Absolutely. So thank you, Eliraz. So we're at this point. Now the attacker gained the credentials of Guti Hernandez, which is application administrator, as we're already aware of. And of course, application administrator can do basically whatever he wants regarding application, which means regarding app registrations and enterprise applications, which exist on the specific Azure Active Directory tenant, which is super, super important role in Azure Active Directory. And our attacker, of course, aware of it, and he would like to take advantage of this role. And what he does next is basically continue with this attack using the credentials of Guti Hernandez that he just set according to his choice. and to access to Hernandez. And basically, he set here the password, the user account, and he connects to Azure Active Directory using the Azure-related module, using the credentials of Hernandez. And now the attacker basically can do whatever Hernandez can do because he runs under the identity of Hernandez. And the following thing that you would like to do for sure is to see which applications exist in this infrastructure because now he's an app administrator. To do so, he uses the following command that you'll see on screen in a minute. This is the command, which allows him to get a list of all of the applications, the app registrations that exist on this infrastructure. One of the applications that comes first to his eye because of its name is the IT infrastructure is a code app. It both include the IT word, which is great for an attacker, and the infrastructure as a code, which is also great because it can give you the indication that this app is probably being used to manage some kind of Azure resources, which of course is what the attacker wants to gain access to eventually, Azure resources. This was the whole goal of the whole point of this attack from the first place. And now it checks if he can find the service principal of this specific application. Service principal, just in case you don't familiar with the term, to keep it simple, is some kind of service account that is attached to an application. So he found the service principal, the service account, which is related to this application, and uses the following command to create a new credential, basically a new password that he can use in order to sign in using the identity of the service principal. So until now, he was Hernandez. From now on, he will be the service principal. Okay, we'll use this identity to continue forward with this attack. So just again, a quick recap, uses Hernandez credentials that he just configured by himself, find out the application of his interest. Of course, that in a real attack, if we had like hours here, you will do some kind of extra enumeration and check all of those applications, et cetera, but we want to be focused. So he used this specific application, he finds this application and uses the app admin role that he has in order to create a new password, a new credential for this application in order to be able to use it. So this is the summary diagram of this step. Used Hernandez credentials, gained access to the service principal of the IT infra as a code app, and now he can continue with his attack. So this is the last attack video that we have. And here you can see that the attacker uses the service principal, the credentials of the service principal that he just gained in order to basically authenticate against Azure, this time using the Azure PowerShell module, which is a module that mainly used to access and to communicate with the, let's say, the resource level of Azure, uses the get AZ resource command to basically enumerate all of the resources that are accessible using this service principal. Just to give you some information about it, this command allows you to basically know, okay, those resources that I see on screen, those are not only resources that exist on the environment, but basically those are the only resources that I actually has permission to interact with in some way. So the attacker finds out that he has access to 4 different resources. Axon Prod VMA, which is one of the virtual machine, as you recall from the diagram. This is one of the production servers that he wanted to gain access to from the first place. In addition to the B server, C server, and to the key vault that we talked about in the beginning. Basically, to everything he needed to gain access to, he can gain access to now using the service principal that he just gained access to using all of the flow that we just showed you. And what he'll do now is first to look at the key vault itself. He wants to see what's inside this key vault. So he specifies the name of the key vault that he found out. And in the key vault, he finds 2 different secrets. The secrets basically are secret values. One of them is related to the application that we talked about in the beginning. So basically this application is the standalone application, which is located on the sensitive servers that we talked about. And you'll see in a minute that he uses this command to get the actual password that are located in this key vault, which is the actual secret, the value that he can use to interact with the application within the server. But he still can't access the server itself. So in order to access the server itself, you need to use some other technique, but we know that he has access to those resources. And he can use one of the technique of his choice. He can use run command, which is one technique, but in this case, he uses additional technique, which allows him to basically reset the password of any local user account that exists on those virtual machines, on those servers. So as you can see in a minute, he uses the following command, which basically allows him to specify to which VM he wants to reset the password of, and he specified the name of the VM that he wanted to gain access to, which is VM A in this case, and he set the credentials that he wants to reset the password of. Of course, he needs to have the permissions to do so. It's not that easy, but he already has those permissions using this service principal. And now he configured the admin A user account and the password of his that he wants to configure. And it's important to say that it's not only a password reset. I mean, this feature is intended to be used for password reset, but basically he used the user account that doesn't really exist on this VM, and this feature basically creates this user account if it doesn't exist. So it's also creation of new users and set this password of the user, and the reset password of an existing user. So in this case, it works for the attacker, and he conducted this part of the attack to gain to set the credentials of a user that he chose, and it did the exact same thing against the two different servers that we talked about earlier. You see, it changed only the VM name to VMB, conducted the same process, set the same credentials, and we just can move forward because it's really just repeat itself time after time. Now it configures the same against VMC, etc., etc. And of course, we will read also the last value in the second key vault that already in the second secret that exists on the key vault that he found out. And of course, this secret doesn't relate it to Axon Corporation. It basically related to you guys. Include a message that say thank you for participating and hope you had fun, but it's only related to this specific part of the webinar. We didn't finish yet, okay? We have a lot of good things coming, so stay with us. So the next part is some kind of recap of the last part that we just saw. The attacker used the service principal, enumerated the Azure resources, find the key vault, found the string inside the key vault, also reset the password, basically created a password and a user account in the servers that he wanted to gain access to. And now, as you can see in this beautiful diagram, he has access to all of the resources in the sensitive resource group that we talked about from the beginning, which is great for the attacker. He managed to gain access to whatever he needed to gain access to. And here is some very high-level summary of what we saw here, because I know it was a lot of information, but it's, in my opinion, it's really cool flow, because as you can see, in all of this flow, we didn't add access to domain administrator. We didn't gain access to global administrator in Azure Active Directory. We basically use some other techniques to gain access to the things that we actually wanted to gain access to without touching the most sensitive user accounts in the organization, which is pretty cool. So just to quickly recap, the attacker gained access to an linear PC, to an linear user account, searched in shares, file credentials of the help desk user account, used PS remoting to basically gain access to the Azure AD Connect server, use the AD internals tool to fetch the sync user account and the password of it, signed in the sync user account, which is the exact time in which he basically did the lateral movement from the on-prem to the cloud in the for the first time, and used the credentials of the sync user account to reset the password of the application administrator, which was Guti Hernandez, added a secret to the service principal related to the IT infra as a code application, read the secrets that were located on the key vault that the service principal had access to, and used the permissions of the service principal to also set the privileges, the credentials of a new user account that he created on the relevant production servers, production VMs. So that's it for the offensive part. I know it was a lot, but now we will see the exact same thing from the defender perspective, which is pretty cool. So Asaf, the stage is yours. Good luck.
Thank you, Alon. I know it's a bit hard to follow you, but I'll do my best. So as Alon mentioned, we're going to go over the investigation and defensive side of things, talk a bit about our out-of-the-box detection, as well as how to investigate some stuff that the attacker triggered. So let's discuss a bit about Hunter's coverage when it comes to Azure. We've had an endeavor to increase the coverage, specifically on stuff that were just demonstrated as part of the attacking phase. And we've added in the last couple of months some very cool new detectors, I believe. We've had suspicious sign-ins with the sync account. So as Alon mentioned, it's very irregular to see the account used to sign into Azure services that are not specifically related to synchronization between the on-prem and Azure AD. And we'll see that in a bit. The second one is soft match sync. Basically, whenever the users are synced, there are two unique identifiers, one that resides on the on-prem AD and one that resides on the Azure AD. And if someone tries to update one of them in the Azure side, it's also might be irregular. And so we create a lead and encourage you to investigate. Extraction of primary refresh tokens. So basically PRTs are sort of session tokens, similar to TGT in the Windows world, and other session tokens from identity providers. Whenever you log in, you get a PRT, and you use that to gain access to other services. So if an attacker gains access to your PRT, he can impersonate you, use your permissions, and basically do whatever he wants. The fourth one was also part of the attack. It's whenever someone adds new credentials to service principal, that might be okay, but it also might be malicious. And so we want to alert on that. And much more. So we have previous coverage we had in the Azure space, as well as those detections that I mentioned, and also some that I did not mention. So I encourage you to go into the portal and see how we got you covered. We've also added asset tagging to the AD Connect server. As previously mentioned, it's a very critical server in the infrastructure. It's quite similar to domain controllers, and you don't want anyone to access it. So we have tagging for that, and we manipulate our scores accordingly. And also something that was performed by Team Axon is a broad threat hunting campaign related to the Azure content, and some of these detectors were actually, the logic behind them was run on all of our customers, and whenever it was needed, the customers were notified. So also something that was very interesting to work on. And I will go into two of the new detectors we created, and we'll explain a bit both of the logic and also how we implemented. So suspicious signing by the sync account. So as we saw, actors can use the account to actually reset passwords or try to gain new permissions that they did not have prior. And so the user is usually used to log into a service called Microsoft Azure Active Directory Connect. That's the name of the service. Whenever you see a sync user logs into a different service, it's quite irregular. We actually checked it on all of our customers, and it didn't show up as much. And so we have a detector that is based on this logic, which creates a lead whenever a sync user logs into a different service. We'll see that in the story in a bit. This is how the lead looks. And if you look closely, you'll see that the account, which name appears here, connected to a different service. In this case, Azure Active Directory PowerShell. And that's basically what Alon showed, that the attacker used the PowerShell module with the sync account. The second detector we'll talk about is multiple VM password reset. So as we saw, threat actors can use credentials for VMs and reset the password in order to gain access to those VMs. Sometimes they don't have access to the VM directly, and so they need to use other credentials in order to reset them. So this detector actually looks for password resets on different VMs in a short time span, in this case, 1 hour. And this is how it looks. If you look closely, you'll see which Azure user did that. And I'm sure that you don't remember the entire UUID, but this UUID corresponds to the service principal that was added new credential, as well as we can see the VMs that the passwords were reset at, and we'll see all 3 VMs, VM A, B, and C, and that's how the attacker gained access to those crown jewels servers. Now we'll go over a story that was created as part of the attacking phase. I'll also mention something very interesting. I personally really liked the story page and the feature. It helps to correlate leads that were otherwise probably not gonna be put together, because I'll mention each of the leads data source, which data source it's based on, and it was also part of the Q&A. But in this case, we'll have different data sources. So we'll have leads that came from EDR logs and events, as well as native Azure logs that also have 3 flavors. We support currently audit, Azure audit, Azure sign-in, and Azure activity. And so it's really interesting. So we'll look at the leads, talk about the correlations, why it's on the same story, and also look at some interesting drill downs and results when proper. So let's go over the first lead. The first lead is actually the enumeration phase in the Windows environment. We can look at the lead and see that Ronaldinho Gaucho has performed 12 different reconnaissance commands. We can actually see those. We'll see them better over here. Sorry about that. We'll see them better over here. So we see the commands executed. We can see the command line as well. And this lead is actually based on the EDR source. So we had EDR logs from the endpoint, and we're able to create a lead for the reconnaissance activity. Second lead is the new device using RDP, again, based on the EDR logs. You can actually see it up here. And it was correlated based on the user itself, which is Ronaldinho Gaucho, as well as the endpoint, which is PRTVM new2. I'll bring it up again. This endpoint belongs to Ronaldinho Gaucho, and that's where the attacker starts from. Third lead is related to the password discovery. So we talked about it a bit, but basically enumerating where the passwords are might be stored. So network shares and stuff like that. Also based on EDR source. And we can see it was correlated based on this SID. And you'll have to trust me, but this is Ronaldinho Gaucho's SID. And we can look at the lead and see exactly which files were accessed by which user. And now we know how Ronaldinho got his credentials, or the attacker using Ronaldinho. This is the first one that's gonna not be based on EDR. So if you see, this is based on Azure sign-in and correlated on this IP address, which is the public IP address of Ronaldinho Gaucho's VM. If we look here, we can see public IP and the IP address, and we can see even the line that shows it's connected. Now we'll go and look at some of the interesting things. So this is the sync account, and it was used from this IP address to log into an irregular service called Azure Active Directory PowerShell. And we can actually look at the user login history, which is a cool drill down that shows us every login event for that specific user. And if we group by the product, we can see that usually the service is used to connect to Microsoft Azure Active Directory Connect. And that actually happens every time the sync process initiates. But there were also multiple logins to other services that are related to Azure, which is really cool and shows the maliciousness of the attack. So this one is based on the Azure audit logs, which is a different kind of log that Azure provides. And we can see that it was correlated again on the same IP address. And actually, I'll go into the lead, but Guti here adds the new credentials here. So Guti Hernandez adds new credentials to this service principal, which is later used in order to perform the attack. And also you can see the service principal, as I mentioned before, and I don't know if you trusted me, but this is in fact the service principal ID for this specific app. And the last but not least, multiple VM password resets. This is based on the Azure activity log, which we can see now we have 4 different kind of logs that were correlated to the same story and each of them indicates a different phase of the attack. So let's say the attacker didn't trigger the first lead, we might catch it in the second one or the third one. And that's how we look at coverage with regards to the Hunters platform. We talked about during the slide, so I'm not gonna go into the lead, but again, this is based on the service principal ID. Let's go back to the slides, and I will let Eliraz bring us home.
Thank you. Yeah, so let's summarize what we have talked about. We demonstrated an attack scenario starting from unprivileged on-prem user and escalated gradually to a privileged access on Azure resources. At no point in time, we add a domain admin or global admin, and yet we were able to move from unprivileged account on-prem to access highly sensitive Azure resources. We also understand that the Azure AD Connect server is a very major component in such attacks and should be treated as a highly sensitive asset. As mentioned before, the Hunters portal include this type of server within the asset tagging. In addition, we saw that application and service principal can be manipulated in various ways to conduct lateral movement and privilege escalation within the Azure environment. And we went over a story on Hunters platform that cover the attack scenario from different angle and on different levels, and show some and present some very insightful investigation context. So that's it. And if you have questions, we will be happy to answer.